Hey everyone, and welcome back to AI Paper Podcasts. We're diving deep into a paper today that really caught my eye. Large language models think too fast to explore effectively.
Yeah, that title definitely makes you think, doesn't it?
It does. It really does.
It makes you wonder if all that speed we usually associate with, AI smarts could actually be holding them back when it comes to exploring new ideas and stuff.
That's exactly it. And, we always talk about how crucial exploration is if we want AI to tackle those really complex problems to be adaptable and not just, stuck in a loop.
Couldn't agree more. The paper actually uses a pretty clever way to test this idea. They use Little Alchemy, too, as their testing ground.
Oh, yeah. I remember that game.
Combine fire and water and you get steam, that sort of thing.
Definitely lost a few hours to that one. But I never thought of it as a way to study AI exploration.
Yeah.
What's the connection there?
Well, think about it. Little Alchemy 2 forces you to experiment, right? You got to try different combinations, figure out the rules of the game to create those new elements. There's no one right answer, so it's a great test to see how well an AI can explore and be creative.
So it's not about solving a specific problem. It's more about understanding the rules and then using that knowledge to make creative leaps.
Exactly.
How did they actually set up the experiment, though?
So they had a bunch of different large language models. LLMs play Little Alchemy too,
Okay.
pitting them against us humans. They wanted to see if the LLMs could match or even beat human performance in terms of discovering those new elements.
So did the AI manage to outsmart us?
Well, the results were interesting. Most of the LLMs actually did worse than the humans, but there was one, the O1 model, that absolutely blew past human performance.
Oh, wow. So one superstar and a bunch that didn't quite make it.
Oh.
How did they actually measure the exploration strategies of these LLMs, though?
They focus on two main strategies: uncertainty-driven exploration and empowerment.
Okay.
Uncertainty-driven is basically trying things you're not familiar with. So say an LLM hasn't used the element earth much. It might be more likely to try it out in new combinations.
Okay. Makes sense.
Empowerment, on the other hand, that's a bit more strategic. It's about choosing actions that open up more possibilities down the line.
Okay.
So, for example, if combining human with other elements leads to more discoveries than combining alien, the LLM would prioritize human. You see?
Right. So uncertainty is about trying new things now, while empowerment is about planning for the future.
You got it.
It sounds like humans are better at that planning ahead part.
And that's exactly what they found. Most of the LLMs were all about that uncertainty-driven exploration, which led to, poorer performance. They were focused on the short-term gains, not the long game.
But O1 was different, right?
Exactly. O1 managed to balance both uncertainty and empowerment, just like we do. And that's probably why it was so successful. And this is where the idea of LLMs thinking too fast comes into play.
Okay, I'm intrigued. How does speed relate to their exploration strategies?
So to figure that out, they used this technique called Sparse autoencoders to peek into how the LLMs were representing these strategies internally.
So they were basically trying to visualize the thought process of the LLM.
Precisely. They wanted to see how these different strategies were being processed and prioritized within the AI's brain.
And what did they find?
They found that in a typical LLM like LMA 3.170B, uncertainty was processed super early on, and it was really closely tied to immediate choices, but empowerment that showed up much later in the processing pipeline.
So the LM might be making decisions before it fully grasps the long-term impact of its actions.
Exactly. It's like making a snap judgment based on what's right in front of you without really thinking about the bigger picture. It's almost as if they're thinking too fast to really explore effectively.
It's like they're so focused on the next step that they miss the big picture.
But why do you think these LLMs are thinking too fast in the first place?
It probably comes down to how traditional LLMs are designed. They're really good at predicting the next word based on the words that came before it, like a supercharged autocomplete.
Right, that's their strength in tasks like text generation. Exactly, but that same mechanism could be limiting their ability to, pause, reflect, and strategize like we do when we're facing a more open-ended problem.
So they need a way to slow down and consider the long game. But is that even possible with how they're currently structured?
There are some hopeful signs. Remember how O1 balanced both uncertainty and empowerment? And there's this new open source reasoning model called DeepSeek R1.
Okay.
It also uses a visible reasoning process, which suggests that with the right design, LLMs can be more strategic explorers.
That's encouraging.
Yeah.
It means this thinking too fast issue isn't a dead end.
Yeah.
But before we get too deep into solutions, I want to understand exactly how they measured this whole phenomenon.
Sure, let's break it down. So they had these LLMs playing Little Alchemy too, like we talked about.
Right.
They took the LLM's current inventory of elements and a history of its past combinations and used that as input. Then the LLM had to pick two elements from its inventory to combine.
Got it.
They did this through prompts, with the LLM outputting its choices in a specific format.
Okay, so they had them playing the game. But how did they quantify uncertainty and empowerment to analyze their strategies?
Uncertainty was pretty straightforward. They looked at how often an LLM used each element. The less an element was used, the higher its uncertainty value.
So if the LLM keeps combining fire and water, those would have low uncertainty. But something like Earth that it hasn't touched much would be high uncertainty.
Exactly.
Makes sense. What about empowerment? That seems trickier to measure.
You're right. For empowerment, they used a neural network that was pre-trained on the game's mechanics.
All right.
This network could predict how many future possibilities a combination would open up.
I see.
So a combination that leads to tons of new elements would have high empowerment, while a dead-end combo would have low empowerment.
So it's not just about the immediate result, but how that result expands your options for the future.
Precisely. And that's a key difference between uncertainty and empowerment. Uncertainty is about trying new things now. Empowerment is about seeing potential down the line.
Got it. And to link these strategies to the thinking too fast idea, they used sparse autoencoders, or SAEs.
Right.
I'm familiar with autoencoders for things like dimensionality reduction. But what are SAEs and how do they use them here?
Think of SAEs as a way to visualize the thought process of the LLM layer by layer. It lets you analyze the internal representations of the LLM, which is crucial for understanding how it's processing info and making choices.
So it's like peeking into the LLM's brain to see what's going on.
Exactly. And what they found with SAEs was pretty revealing. In a traditional LLM like Llama, the uncertainty values were processed super early on in the network, while empowerment showed up much later.
So the LLM is focused on uncertainty at first, trying new things.
Yeah.
But by the time it gets around to empowerment, the decision's already been made.
Exactly. That's the thinking too fast problem in action. The LLM is making choices based on its initial uncertainty-driven impulses without fully considering the long-term strategic implications.
That makes a lot of sense.
Yeah.
So it's not that they're just fast. It's the order they process information in that could be hindering their ability to explore strategically.
Precisely. And to be sure about this, they did some experiments where they messed with the LLM's internal representations.
What do you mean by messed with?
They targeted the layers in the sparse autoencoder that were most strongly linked to either uncertainty or empowerment. They tried things like ablating these layers, basically silencing them.
Wow, so it's like temporarily disabling parts of the LLM's brain to see what happens?
Exactly. And what they found was when they ablated the empowerment layer in Llama, it barely affected performance. But ablating the uncertainty layer made the LLM's performance tank.
Interesting. So uncertainty seems to be a major driving force, even if it's not the best strategy for exploration here.
It seems that way. They also tried amplifying or weakening the activity of these layers, but those mostly made things worse. It highlights that there's something more fundamental about how these strategies are processed that needs to be addressed.
This is really interesting. So we've seen how they measured this thinking too fast thing. But did they offer any solutions or directions for future research?
Absolutely, and that's what we can dive into next.
Okay, so we've seen how they measured this whole thinking too fast phenomenon. But did they offer any solutions or at least some directions for future research?
Oh, they definitely did, and that's where things get really exciting. You see the success of that O1 model. It suggests that maybe we need to rethink how we build LLMs in the first place.
Okay.
Like maybe instead of just focusing on speed and efficiency, we need to design them with exploration in mind from the ground up.
So we need to go beyond just predicting the next word and build models that can actually pause, think things through, and strategize.
Exactly. And the paper actually points to some interesting work that's already happening in that area. Like remember that DeepSeek R1 model we talked about?
Yeah.
It uses a visible reasoning process so we can actually see the steps it takes to reach a decision. And that transparency is huge. It helps us understand how these models are thinking and where they might be going wrong.
So if we can understand their thought process, we can design better ways to train them and intervene when they get off track.
Absolutely. Another interesting direction they mention is using techniques like reinforcement learning to train LLMs for exploration. By rewarding them for discovering new elements in Little Alchemy too, we can encourage them to develop more strategic approaches.
So it's not just about changing the architecture, it's also about using the right training methods to shape their behavior.
Exactly. And this is where things get really fascinating. This research opens up a whole new way of thinking about AI, one that focuses not just on how well it performs, but on the actual cognitive processes that make up intelligence.
So we're moving from just building AI to actually trying to understand how it thinks and learns.
Precisely. And this change in perspective could totally revolutionize not just AI research, but also fields like psychology and cognitive science.
This paper has definitely given us a lot to think about. It shows us that we need a deeper understanding of AI, one that recognizes the importance of both speed and strategic thinking.
I completely agree, and it really highlights how important continued research is. We've only just scratched the surface of what AI can do, and by tackling these limitations, we can unlock so much more potential.
Well, on that note, I think it's time to wrap up this episode of AI Paper Podcasts. Thank you so much for joining me today and sharing your insights on this really thought-provoking paper.
It was my pleasure. It's always great to dive into these topics with you.
And to all our listeners out there, thanks for tuning in. If you enjoyed this episode, don't forget to subscribe and leave us a review. We're always on the lookout for new and interesting papers to discuss, so if you have any suggestions, feel free to send them our way. Until next time, keep exploring and stay curious.